Today I am going to revise kinematics for you. I am going to use these three questions that I saw that I write on the board for you. I know that they are hard to see, but I am going to read them and explain them and solve them. Don't worry. So, in kinematics, we have four basic formulas. One of them is, first one is V is equal to U plus AT. Second one is V squared is equal to U squared plus 2AS. Third one is S is equal to UT plus 1 over 2AT squared. And fourth one is equal to S is U plus V over 2 times T. Here U is initial velocity, V is velocity, S is displacement, and T is time, A is acceleration, deceleration is negative, acceleration, and basically we use three graphs: displacement time graph, and here gradient is velocity. We have velocity time graph, gradient is acceleration, and area under the graph is displacement, and as the last graph we have acceleration time graph. These are the things that we need to know to be able to solve M1 Mechanics 1 kinematics questions. Let's read question 1. N is constant. In N1 we don't have any variable acceleration. Acceleration is always constant in kinematics questions. So here the car passes point A with speed. So can we find the acceleration here? What is the formula that we can find the acceleration? We know U, we know T, we know the displacement between A and B. So if the question wants us to find the acceleration, we can use the third formula. Because in the third formula, we know U, we know T, we know S, but the only unknown is acceleration. So let's use the formula UT plus 1 over 2 AT squared, so that we find the acceleration between points A and B. So 36 is equal to 6 times 4 plus 1 over 2 A times 4 squared. So 36 is equal to 24 plus 8A. 12 is equal to 8A, and acceleration between points A and B is 12 over 8, 1.5 meters per second squared. And let's carry on reading the question. At point B, car decelerates. Now we reach to point B, and car starts to decelerate. So now we know the acceleration, we can find the velocity at B. To be able to find velocity at point B, V is equal to U plus AT, and here U is and time is 4 seconds. So velocity at point B is going to be 12 meters accelerated. That means the velocity, the motion is going to change. It was accelerating with constant acceleration 1.5, but after passing the point B, the car is going to decelerate. That means the motion is going to change. So at point B, motion is going to change. So at point B, U is 12. This is the initial velocity of the new motion. And we don't know the acceleration after B. It is going to be a deceleration. That means we are going to have a negative acceleration. And that negative acceleration is -2. It is given there. And reaches the second. So V is equal to U plus AT. 1 is equal to 12 plus -2 times T. T is equal to 11.2, 5.5 seconds. The time between points between points B and C. This is the time elapses between point B and C. This is the time for the car to reach from B to C. And what is the distance displacement between B and C? UT plus 1 over 2 AT squared. U is 12. Time is 5.5. 1 over 2 minus 2, 5.5 squared. So distance between B and C is going to be, let's use the calculator to have the exact value. It is going to be 12 times 5.5 minus 5.5 squared, and the answer is 35.75. 35.75. This is the displacement B and C. Sketch let's answer the parts of the question. Now we understand the question. Let's give the answers. Sketch velocity time graph for the journey of the car. Velocity, and this is time. Time is in seconds and velocity is in meters per second. And we start at point A with a velocity of 6. This is point A, and reach to B with 12 meters per second. At point B, the speed is 12 meters per second, and we reach B in 4 seconds. The car reached to B in 4 seconds. Then a further 5.5 seconds elapses. So this is, here we have 5.5 seconds. That means at point C, the time is 9.5 seconds. And at point C, the speed is 1 meter per second. This is the velocity time graph for the journey of the car. Find the total distance covered. Either we can calculate by area under velocity time graph, or we already found the we know the displacement between A and B, and we already calculated the displacement between B and C. So the total distance covered, displacement of the car is 36 plus 37.75, that makes 73.75 meters. This is the total distance covered by the car from A to C. This is how we read the question, and these are the solutions of the parts of the question. Do you have any questions? If you don't have any questions, I am going to solve question 2, but before that I am going to send you the solutions of the question 1. Now I am going to carry on with question 2. And it is actually very similar to this one. I am going to leave the information here, the revision of the information that we need to solve any of the kinematics questions. And this is the question 2. I know it is hard to read, but don't worry, I am going to read it for you and have a revision summary of the question here. And let's clean the board, have empty space to solve question 2. Yes, let's read question 2 and solve it. A lift is initially at rest. Initially at rest means U is 0. The lift accelerates with an acceleration of v is 4 meters per second. So let's find the time for the lift to reach from 0 to 4 meters per second. So 4 over 2.5 time is 1.6 seconds. It then moves with constant speed for now. The motion is going to change. Constant speed means for the second part of the journey, for the second part of the motion, acceleration is 0 and u is what? 4 meters per second. And the time is t here. Finally decelerates, so we have another motion here. The motion is going to change again for the third time. U is 4 for the third part of the journey, and we have a deceleration here, and it means we have a negative acceleration, and time is 3.2 seconds before coming to rest, and the final speed is going to be 0. So u is 4, v is 0, v is equal to u plus at. This is the first formula there, and most suitable one to find the acceleration, actually the negative acceleration. 0 is equal to 4 plus a times 3.2 minus 4 is equal to 3.2a. Acceleration is equal to minus 4 over 3.2. So acceleration is equal to minus 1.25, minus 1.25 meters per second square. That's the acceleration for the third part of the journey. Here, again, it was at rest, u was 0, reached to a velocity of 4 meters per second with an acceleration of 2.5 meters per second. So it took the lift 1.6 seconds to reach a speed of 4 from 0 with an acceleration of 2.5 meters per second square. That is the first part of the journey. At the second part of the journey, travels with that speed 4 meters per second without any acceleration. Why without any acceleration? Because the velocity was constant for t seconds. And in the third part of the journey, the speed was 4 and reaches a speed of 0, comes to rest in 3.2 seconds. So the deceleration is 1.25 meters per second square. And let's continue reading the question and answer. The total distance covered by lift is 32 meters. Let's have a velocity time graph for the journey of the lift. It was 0, comes to 4 in 1.6 seconds. Carry on with that 4 meters per second for t seconds. So we reach to a time of 1.6 plus t. Then carry on with, starts to decelerate for 3.2 seconds. That means the total time for the journey is 4.8 plus t. 1.6 plus t plus 3.2 is 4.8 plus t. And the total distance traveled by lift is given in the question, and it is 32 meters. So here, when you look at the shape there, it's a trapezium. And what is area of a trapezium? Let's draw a quick sketch for a trapezium. If this is A, this is B, and that's the height, area is equal to A plus B over 2 times the height. So total distance traveled is the area under the velocity time graph. So if this is t, that's distance is t there, that is going to be t as well. So when you check the graph there, this is t, that length is 4.8 plus t from 0 to there, and the height is what? When you check the height, it is 4, and the area is there, it is 32. So 16 is equal to 2t plus 4.8. 11.2 is equal to 2t. So t is equal to 5.6 seconds. And this is the answer for question 2. You need to know, you need to remember the area of a trapezium, and you have to recognize that this is a trapezium here. Yes, do you have any questions? Checking my messenger for your questions and sending the picture of the board to you in a minute. This is the answer for question 2. Finish sending the question. Yes, I see that we don't have any questions. Now we are going to use question 3 to have a revision about threefold. That's a special case for kinematics. I'm going to erase the board, leave the questions there, which you cannot read very easily. But don't worry, I'm going to read question 3 for you. But before that, I am going to do a quick revision about freeform. We have 3 types of freeform. Freeform. First type is with if you have u0 and it is at rest, and leave the object from a height. It is there, and we are going to leave the object to fall without an initial speed. It is going to fall freely. Here u is 0. The first movement, when you check the movement, it is going to go towards ground. The direction of the movement is downwards. And the acceleration here is also g, the gravity, which we have to take as 9.8 meters per second square. Here v is equal to u plus at, where u is 0, acceleration is 9.8, and substitute t there. And you have to remember that it is downwards. And in mechanics we have the chance to say that because the initial direction is downwards, choose initial direction as positive, which is downwards in this case. This is free fall. First type of free fall without any initial speed. And S will be ut plus 1 over 2 at square. Here u is 0, so this one is going to be cancelled out. and acceleration is 9.8 t squared. This is how we find the displacement, actually the height of the object to fall. Now, second type. Here again we have a height, we have u, we have the object there, but we are going to throw it downwards. We have an initial speed, but we are going to throw it. The initial direction of movement is downwards. So downwards direction is again positive. We have u there, the initial speed, because we are going to throw the object, not leave the object to fall. We are going to throw the object. It is going to have an initial velocity there, pointing downwards, going downwards. Acceleration is again 9.8 meters per second square, which is the gravitational acceleration. Call it g. And we have the third type, which is the case in question 3. Actually, the hardest of all the 3 cases. U is upwards. We are going to throw the object upwards. So the initial speed is upwards. The velocity, the first motion is upwards. So upwards direction is positive. Then the downwards direction is going to be what? Negative. The initial speed is upwards. The first motion is upwards. The the positive direction is upwards. But here again we have the acceleration as gravity, but this time it is going to be negative because gravity is always downwards. It is against the initial direction. And here, remember, the question will tell you that it is thrown up. In the third case, the object, it is going to be thrown up. And that will be the case for question 3. Now, let's read question 3 and try to answer it. Here, an object is thrown up. That means this is thrown up. This is thrown down. And there we leave the object and it has to go down. This is thrown up. This is thrown down. So it is thrown up. We are in the third type. So, an object is thrown up with an initial speed of 16 meters per second. So we have u, which is 16, and goes up means our initial direction is up. So that's the positive direction for us. And let's carry on reading the question. From a height of the object from ground, this is our object, from ground is 20 meters. This is the ground. Object is at that point which is 20 meters above from the ground. And then moves up and comes down. Comes on the ground. And what is the acceleration here? Acceleration is negative g, because it is always downward, but we choose our initial direction which was up as positive, so pointing downwards is negative. And remember, you have to remember that gravitational acceleration always due to the ground, always points to the ground, which is always downward. So acceleration is 9.8 meters per second square minus g for this question. Now, this was the initial position of the object, and it falls on the ground. What is the displacement for the object? What is the formula? We have a very simple formula for displacement. It is equal to final position minus the initial position. So, if final position is there and initial position is there, and this is our reference point, final position will be minus 20 from the initial position. The object falls down from 0, from the origin. So displacement will be minus 20 meters. It was at 0, it was at the reference point, it was at the initial position, and when you check the final position, it falls 20 meters down, goes down, and in this question, going down is negative. Going up is positive because we choose the direction of the initial motion as positive, as our positive direction. It was at 0 at the initial position, at the initial second. When we check the final position, that final position is 20 meters below the initial position. Being below is negative. Because going up is positive, so going down must be negative. So we know S, the displacement, we know the initial time, we know the acceleration, so we can find the time of flight. S is equal to ut plus 1 over 2at squared minus 20 is equal to 16t plus 1 over 2 minus 9.8 t squared. Acceleration is minus 9.8, you have to remember that. So minus 20 is equal to 16t minus 4.9 t squared. 4.9 t squared minus 16t minus 20 is equal to 0. And as you see, we have a quadratic equation here. And by solving this quadratic equation with the quadratic formula, A is 4.9, B is minus 16, C is minus 20, and the root formula is 41, and T2 is minus B minus or plus B squared minus 4AC divided by 2A. So T will be 16 minus or plus 16 squared minus 4 times 4.9 times minus 20 divided by 2 or 2 times 4.9. So T is going to be let's calculate and the answer is for time t is equal to 4.23 seconds, and velocity at the end when the object hits the ground, the initial speed was 16, Distance, displacement is minus 20. Acceleration is minus 9.8. So I am going to use v squared is equal to u squared plus 2as. V squared is going to be 16 squared plus 2 times minus 9.8 times the displacement, which is minus 20. So v squared is equal to, by the help of the calculator, 16 squared plus so v squared is equal to 648. So velocity is going to be square root of 648, which is equal to 25.2, 25.3. It is 25.46. 25.46 meters per second is the velocity of the object when it falls on the ground. Yes, this is the end of the revision for kinematics questions. These are exam type questions. You may find very similar questions to these that I wrote on the board. These are original questions written by me, but you may have, you may see questions which are very similar to these in the past papers and maybe in the exam as well. So let's send the pictures of the board of solution of question 3 as well and finish the lesson today. And this is the end for the revision of kinematics. I used 3 different questions for you to revise that topic. Hopefully I will do some revisions for statics, dynamics as well. Yes, bye from now.